And there you go.
Alrighty, so for this video, I'm going to be doing chapter 3, section 6, which is a summary of curve sketching. Woohoo! Alright, so the importance of curve sketching is when you're sketching a graph, the graph of a function either by hand or a graphing utility, remember that normally you can't show like the entire graph. The decision as to which part of the graph you choose is often crucial. By seeing both views, it is clear that the second viewing window gives a more complete representation of the graph. But would a third viewing window reveal other interesting portions of the graph? To answer this, you need to use calculus to interpret the first and second derivatives. So here I have just the basics of curve sketching, like what you're going to want to find. So you're going to want to find the x-intercept, the relative extremas. You're going to want to figure out whether or not your equation does or does not exist, because if it does not exist, then there's really no point in continuing with the problem. You're going to want to figure out points of inflection and where the intervals increase and decrease. And here in the black, I just have little steps of trying to explain how to do them. So define the x-intercept, You're going to want to factor the equation that you're given and then use the zero product property to find the x value for the x-intercept. To find the extremas, you're going to want to do the first derivative of the equation that you're given, and then again use the zero product property to find an x value. And then the very first thing you're going to want to do is figure out whether or not your equation is d/e. So basically, you just want to look on the graph. Are there any asymptotes? Are there any places where your equation is going to equal 0 and it's going to not exist for that portion of the graph? To find points of inflection, you're going to do the second derivative of the equation, and again, zero product property, find x values and use those. And when you're doing where the function increases and decreases, you're actually going to use the x values from here. You're going to use the extremas, and you're going to plug these into a sort of number line and use a graphing utility to find the graph of the function and to look and see where it is increasing and decreasing. So to exemplify this, I am going to use a sample problem that I have done previously. Our function is going to be f of x equals x to the fourth minus 6x squared. Alrighty, so the first thing we're going to do is find the x-intervals. As you can see, this is an orange, so I'm using an orange marker in order to color code it for you guys so you know what's going on. So as it says over there, we're going to factor the equation. So I see here that I have an x squared, x to the fourth. Pop that x squared out in front, gives me x squared minus 6. And then use my zero product property in order to find points. And set this all up, use little algebra math stuff, and you get 0 and plus and minus root 6. And those are our x-intercepts. Now to find the extremas, we're going to do the first derivative of the equation, and again use zero product property. So derivative, you pop the exponent out in front, minus 1 from the exponent, and you get this, and then you use zero product property. Factor out that 3x there, actually 4x. You get x squared minus 3 equals 0. Set those up separately. And you get x equals 0 and x equals plus and minus root 3 for your extremas. Points of inflection, just to save a little room on the board, I'm going to go down here. So we're going to do second derivative and dpp again. So we're going to use our first derivative over here to get to our second derivative. It's going to give us 12x squared minus 12 equals 0. Factor 12 out, x squared minus 1 equals 0. And we get x equals plus and minus 1. Sorry, I just had to go back to my notes. And we're going to find whether the function increases or decreases. So for this, I'm going to draw a graph that I already have from before. And as you can see, it is decreasing, increasing, like that. But just to get a better idea, we're going to take our extreme values, so this, and set them up. So we're going to have negative root 3, 0, and root 3. So as you can see, from here to about where negative root 3 would be, it is decreasing. So we're going to put a negative there, and then from negative 3 to 0, it is increasing. Again, from 0 to root 3, we have decreasing, and from here on to infinity, we have increasing. So here we have where our functions increase and decrease. Another thing to note is that on this graph, you see that there are no asymptotes, no places where the function anywhere could equal 0. So that means that our function does exist. I'm going to write that down because that's cool. Because that means we can continue with the problem. So this has been a summary of curve sketching. Again, just to go back through, we have our x-intercept, points of inflection, relative extremas, where it increases and decreases, and does my function exist? That is the end.